Now we will talk about the head of the solar system, the head of the solar family, and that we know is Sun. Now we will be discussing about Sun. The first sentence which I said that Sun is the head of the solar family or Sun is the head of the solar system. So it is head of solar system. Now we all know Sun is a star. Sun is what? Sun is a star. Why is it a star? Because it has got its own light. It emits its own light. So Sun is a star. It is a star. And you know it is which kind of a star? Is it very big or is it very small? Neither it is big nor it is small. It is just a medium sized star. The thing is that Sun is the one which is very near to us. It's very near to us, and so we can see Sun very nicely, and we can get heat and light. We have a lot of benefits from the position, the distance of the Earth and Sun, which is very appropriate. So coming back to the point, it is the head of the solar system. It is a star, or I can write it is a medium sized star. Medium sized star. And it is a luminous object. What is the meaning of luminous, children? Luminous means object which has got its own light, which emits light, isn't it? So it is which kind of object? It's a luminous object. It is a luminous object. And what do we get from Sun? We are able to survive because of Sun. We get heat and light. I am not writing the things in the complete sentence, children. I am just writing incomplete sentences, sometimes the keywords. So we get, what are we getting from it? We are getting heat and light. Due to the correct appropriate distance between the Earth and the Sun, it is quite possible for us to be there on the surface of the Earth. So we get heat and light from the surface, from the Sun. Now, what is the composition of the Sun? It is made up of what? So, and why does it emits light? What is there in that? So basically, children, Sun is also known as hot ball of fire. Hot ball of fire. Why it is known so? Actually, no, the temperature of the Sun. The temperature of the Sun. Now this is Sun. So the temperature of the Sun on the outer core. This one I am talking about. This one is the outer core, and here this one is the inner core. So definitely the temperature at the inner core and the outer core is quite different. So when we talk about the temperature at the outer core's temperature is 6000 degrees Celsius. Outer core temperature is 6000 degrees Celsius. And inner core temperature, can you imagine how much is it? The temperature in the inner core is how much? I have written over here, outer core's temperature is 6000 degrees Celsius. That means here the temperature is 6000. But what is in the center? How much the temperature is? So children, this one is 14 million degree. Where to put degree and where to put Celsius now? So it's 14 million degree Celsius. So high temperature. What is going on inside this? Why so high temperature is there? So why temperature is so high? Actually, nuclear reactions are going on. Nuclear reactions are going on in the inner core. Now we will be discussing about the fission and fusion in next class, maybe in 9th standard or 10th standard. So I will be discussing that in detail over there. So for here what I am talking about, that nuclear reactions are going on and hydrogen is combining. Hydrogen is combining to form helium, and in this process lot of heat is produced, and in this process lot of heat is produced. So what is sun? Sun is the medium sized star. It is a luminous object. It has got its own light. It gives us heat and light. The distance of the earth and sun is appropriate for us, and that is the reason we are able to use sun's heat in a positive way, and it's not burning us. Now apart from this, when we talk about the temperature, it's very hot. It's a burning ball or ball of a fire, and the temperature at the outer core, is 6000 degrees Celsius, and in the inner core what is the temperature? It's 14 million degrees Celsius. Now actually nuclear fusion and fusion is taking place, and the hydrogen is combining to form helium. So due to this fusion reactions, nuclear reactions, lot of heat is produced, and this heat is the combination, like when the hydrogen is combining to form helium, heat is produced, and this heat is the only heat which is coming out of the sun. Now what is more about what else I have written over here? Yeah, this much only I have written over here. Now if we talk about the composition of the sun, what all are present in the sun? So we know that hydrogen is present, helium is present. Apart from this, what else is there? So carbon is present, nitrogen is present, sulfur is present, neon is present. So all even iron is present. So all these forms the sun. Definitely they have got their own their percentage. Some is present in high quantity, some is present in low, but these all forms the or makes the sun. This is the composition of sun. This one is the composition of the sun. This all makes the surface of the sun. Now when we compare sun with the earth, definitely we all know sun is very huge. Sun is very big, and the diameter is about, is it visible from here? Yeah, it is visible. So the diameter is 110 times diameter is more than earth. So 110 times. I have not written times over there. Its diameter is 110 times more than the Earth. So it's huge ball of fire when we compare it with the Earth. When we compare it with the other stars, it is a medium sized star. You know, the stars, various stars which we are seeing in the sky, it is quite possible that there are many stars which are quite bigger even than the sun. But the thing is that why they are looking so small? Because the distance. The distance of those stars, if we talk about the distance between the Earth and those stars, so that is quite more, and the distance between the sun and the Earth is less, and that is the reason it looks so huge. Now, sun emits the heat and the light and the sun rays, we say. So the sun rays take how much time to reach the surface of the Earth? So it takes 8 minutes and 29 seconds. There is no place now to write, so I will write over here. Sun rays takes 8 minutes and 29 seconds to reach the surface of the Earth. So, actually when we have to calculate the distance between the two heavenly bodies, so this distance is very high, and it's not possible to calculate these distance in kilometers or meters or certain these kind of units. So we all know that we use one more unit, and that is light year. What is the meaning of the light year? The astronomical distances are always calculated or considered in, it is always seen or taken in the form of light year. Why? Because the distance is very high, and it's not feasible to calculate this or to take these distances in kilometers or meters. But then what is light year? What is the meaning of light year? So the distance travelled by light, we are talking about light year. So the distance travelled by light in 1 year is light year. So distance travelled by light in 1 year. The distance travelled by light in 1 year is known as light year. And we have discussed that sun rays takes 8 minutes and 29 seconds to reach the surface of the Earth. I am saying again this one is the nearest one. Now when we talk about after sun, like which is the one which is very near to us, so that is Alpha Centauri, and this one is what? Alpha Centauri and Proxima. Proxima Centauri. Now these are the one which are present. When we say that the sun is the nearest one, so after sun, these are the two which are, we can say that these are some which are nearer after sun, and it is, the distance is 4.3 light year. The distance is 4.3 light year. Now we'll talk about that in 1 second light travels how much distance. What we'll be talking about, that in 1 second, just 1 second, done, 1 second is over. In this 1 second, how much does the how much distance this light covers. So light travels I will just keep on writing the zeros over here. Light travels, see, 1, 2, 3 kilometers, okay. So light travels how much distance? This much distance in 1 second. When light takes, like in 1 second, if I move 1 kilometer, isn't it? It's like this, in 1 second if I move 1 kilometer. So similarly, if light is traveling this much kilometer in 1 second, so light travels how much distance? Okay, how much distance in 1 year? We know in 1 second light is traveling such a huge distance. So in 1 year, how much does the light travels? So what has to be done? We'll take this distance, and now I am talking about the days. In 1 day, how many days in 1 year? In 1 year, how many days are there, children? 365, and you know we have to calculate that 6 days also, so 1/4 days, so it will be 0.25. These are the kilometers which the light travels in 1 second. Now this much is these are the days. In 1 year we have got these many days. Now if we talk about the hours, we have got 24 hours. If we talk about the minutes, we have got 60, like 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So just need to calculate this, and it will come to it will give one of the figure, and which will be 9.46 into 10 raised to power 12 kilometers. Now this is the distance which is covered by light in 1 year. Light is also, or we can say that this distance can also be calculated in unit parasec, per sec. So 1 parsec is equal to what? It is equal to 3.2. It is equal to 3.2 light year. So this one is also the unit, one of the unit to calculate this. So what we are discussing here? We are discussing about the sun. What is sun? Sun is a burning or it's a very hot ball of fire. It has got a lot of things inside it. Many reactions are going on. Hydrogen is combining to form helium. The reaction, we can say the nuclear reactions are going inside it, and the outer core has got the temperature of what? It has got temperatures around 6000 degrees Celsius. Here the temperature increases, it becomes very high, and it becomes around 14 million degrees Celsius. Now all the composition, if we talk about, so hydrogen, helium, carbon, nitrogen, sulfur, iron, neon, all this forms the sun. Sun is a luminous object, that means it emits its own light, and this is all which I have written over here. It gives us heat and light, and its diameter is 110 times more than that of the surface of the earth. Now the sun rays takes only 8 minutes and 29 seconds to reach on the surface of the earth. Now if we talk about the light year, the distance travelled by light in 1 year is known as light year. Now, if we talk about in 1 second how much distance is covered by light, so it is this much distance is covered in 1 second. So, just we have calculated, we have taken the days, the number of days in a year. 1 day is made up of 24 hours, then 1 hour is made up of 60 minutes and 1 minute is made up of 60 seconds. And then we have calculated this, and so this all makes the how the astronomical units are calculated, or astronomical distances are calculated. Astronomical distances means what? The distance between the two heavenly bodies. Distance between the two heavenly bodies cannot be calculated in the other units like kilometers and all this, because the distances are very high. So, we need to have certain bigger units, and light year is a bigger unit. Now, parasec is also what? It is also one of the astronomical unit. It is also one of the astronomical unit. So, we can see over here that how fast the sun rays reaches the surface of the earth, and why we need to calculate all these distances in light year. As just now we have discussed that the distance is very high, and so we calculate this distance in light year. What is light year? Distance which is travelled by light in 1 year. So, this is all about the sun, which is the head of the solar system, which is the head of the solar family. So, solar system is completed, in which we have discussed about the sun, the 8 planets, then we discuss about the asteroids, the comets, the meteors and the meteoroids. Definitely we will be discussing also about the Pluto little bit, but before that please note all these points. We will talk about stars now. What are the stars and why do they twinkle? Are they smaller? So small as we really look, when we look at the sky, they appear really very small. So, really are they very small? So, I will talk more about this in stars. Actually, stars are huge bodies. Stars are very big. We know, we have discussed just now, that even sun is a star, and sun is extremely big. It is a medium, and then too because of its big size also, we are saying that it is a medium sized star. So, just imagine the size of the big stars. So, we cannot judge about the size of the star just from the surface of the earth, because the distance between the stars and between the earth and the stars, this distance is very high, and that is the reason we cannot make out that exactly what is the size of these stars which are twinkling in the sky. And sometimes we feel that the stars are not shining brightly, but it is also affected by the area where we are standing and looking and gazing the sky. This brightness can be affected only in our vision, not they are affected. But why it is not clear for us many a times? Just because of the pollution. So, if we really want to see stars clearly, we need to go in some open area, open and wide area where we can see stars properly. Do these stars move away somewhere? They go in the daytime? No, they are there only in the sky. But why we are not able to see these stars in daytime? Because of the glare of the because of the glare of the sun. As sun is very hot, it's near to us, it's emitting heat and light continuously, and because of the glare, because of the shine, because of the brightness of the sun, we are not able to see the stars in daytime, but the stars are there only. What we will write first of all? Stars are huge bodies, Again I will be writing in small incomplete sentences. These are small huge bodies. Distance between stars and us is very high. And so they look like very tiny or very small object. These are luminous object, isn't it? Luminous. What's the meaning of luminous? Just now I have discussed the meaning of luminous. That means they have their own light. They emit their own light. Have or emit their own light. So these stars are the one which has their own light, and we cannot say that the stars are very small because our distance is very big. And stars are actually what? They are huge bodies, they are luminous bodies, they are continuously emitting light and heat. Now, when we talk about the colors of these stars, the colors of the star can be of red, it can be yellow, it can be of different colors can be there. So all these colors, like it can be red, yellow, it can be blue. So all these color depends upon what? Their temperature. It depends upon their temperature. Depends upon their temperature. So it all depends upon their temperature. Now, when we look at the stars, we feel that they are moving. We are focusing on any star, we'll find that these stars are moving, but these stars are fixed in respect to the other stars. Are you getting my point? Actually, what is happening when we move in train? We are sitting inside the train, and when we move, when our train starts moving, what do we feel? That the platform and all the things, all the passengers, all the bookshops, all the shops, whatever is there on the platform is moving in the opposite direction. Same is the case with the stars also. We are there on the surface of the earth, and when we look at the sky, we feel as if these stars are moving in the other direction. But why is it so? Children, stars are fixed. Stars are in fixed position with respect to other stars. But we all know Earth moves in which direction, children? How does Earth moves? Earth moves from which direction to where? It moves from west. It moves from west to east. Now, when Earth moves, when we are moving from west to east direction, so the star appears to move. Okay, so the stars appears to move from east to west. Please remember the example of the train, that when you sit in the train and the train starts moving, you are moving in one direction. But what do you feel? Even if the other train is standing there on the platform, what you will understand that the other train is moving opposite to your direction. Platform is moving opposite to your direction. Why? Because we or when you are sitting in the train, you are moving in, and so all the things appear to move which are left behind. You are moving, these are the two things, you are moving, and so this one is left, and so automatically it seems that these things are moving in the opposite direction. You are moving here and these are moving here. In the same way, when we look at the sky, we all know the earth is moving from west to east. But what do we feel? We feel that all these stars are moving from east to west direction. Why? Just because the earth is moving, so it gives an it gives a kind of feeling that all these are moving, or it appears as if all these are moving from east to west direction. That is the reason we feel that the stars are moving, but actually these stars are at a fixed position with respect to their with respect to the other stars. With respect to the other stars, always remember. Now, when we talk about the twinkling of the stars, whenever we say star, we will always say twinkle. So why do these stars twinkle? Stars have their own light, they are emitting light, but then this light, when reaches to our earth, our surface, it passes through various layers of the atmosphere. The light of the stars, passes through various layers of atmosphere. This you will read in detail in 10th standard, that how does the and how and why the star exactly twinkles, why do they twinkle. So in short, here we will be talking, so just this one is enough, that when the this light is coming out of these stars, they to reach the surface of the earth, they have to pass through various layers of the atmosphere, and due to the disturbance in the layers, due to the various disturbance in the layer, the light twinkles and the stars appears to be twinkling. Now, so few things are very clear to us. Now, one more thing which I have discussed, that do these stars go somewhere in the day? No. So stars are present in day also. And right this side, stars are present. Stars are present in day also. But why cannot we see? We cannot see because of the brightness of the sun. We can't see because of the brightness of the sun. So because of the brightness of the sun, we cannot see the star, but the stars are actually there only. By looking at the stars, we cannot judge about the size of the stars because of their distance. These are the huge bodies which has their own light, that means these are luminous objects. They emit their own light, and why do they twinkle or they appear twinkling? Because the light when reaches to our surface, it has to pass from various layers of the atmosphere, and so they appears twinkling. they moves or they are there at the fixed position. Actually we are moving, earth is moving, and so we feel that they are also moving. So this is all with the stars. They are like the different colors are also there, blue, red, yellow. So why this one is there? Because of the temperature, difference in the temperature. Obviously the temperature of the stars are also very high, as we know that even the sun is a star and sun is continuously emitting heat and light. The temperature there is very high, but the distance between the sun and the earth is less, and so we can see huge effect of sun's heat and light. We can see sun is a big star, rather the other stars which may be much bigger than the sun, we cannot see them as big as sun because the distance is more. So that's all with the stars, and now we will move to the next topic. Please note all these points.